Okay, listen dear students. Already in the last class, we have discussed 25 questions. Let's see the 26th question, how to solve. It's very easy only. So, radioactive decay of phosphorus 32 isotope. Radioactive means radioactive reactions all are first order reactions. Means already they only gave. It is going to first order kinetics. Then its half-life period is 13.4 days. Then how long time it takes for completion of 95% of the reactant converted into product, that we have to calculate. For calculating that time, first we have to find out K value. See, for first order reaction, K is equals to what is the formula for first order reaction? K 0.693 by T half. Okay, so just T half value they gave, that is you have to substitute 0.693 by T half is equal to 14.3 days, is nothing but its half life period. On simplification will get 0.0485. What are the units for this? Days inverse. The units is days inverse. Okay, K value we know that. Now we have to find out T. Okay, we know that K is equals to 2.303 by T into log A by A minus X. This is the first order reaction rate constant formula. Now we have to find out T. If A is equals to 100%, okay, then A minus X is equal to 100 minus 95. 100 minus 95 is equals to 5. At that time, we have to find out T, we need to find out. Now, T is equals to 2.303 by K. K value how much? 0.0458 into log 100 by 5. Log 100 by 5. Okay, log 100 by 5 means log 100 is nothing but 2 minus log 5. C is nothing but 2.303 by 0.0485 into log 100 is nothing but 2 log 10. 2 log 10 minus log 5. Okay, is nothing but log 5 is nothing but 0.7. 2.303 by 0.0485 brackets 2 minus 0.7. 2 minus 0.7 is nothing but 1.3. Then 2.303 by 0.0485 into 1.3. This is on simplification. We'll get approximately 61.85. 61.85 is nothing but 62 days. So for decomposition of reactant P32 isotope into 95% means 95% is decomposed. For that it takes how much time? 32 days it takes. 32 days time is required. Okay, sorry, not 32, 62 days. So the answer is third option. Third option is correct. Okay students, let's see the next one. 27th question, 20% decomposition of H2O2 in the presence of acid requires 5 minutes. The time required for 50% decomposition. See, 50% is nothing but half-life period. T half we need to find out. See, for this, we have to find out K. K is equals to 2.303 by T into log A by A minus X. log a by a minus x. Okay, students. Now the t is equals to 5 minutes. T is equals to 5 minutes time. At that 5 minutes time, 20 percentage of H2O is decomposed. The A is equals to 100 percentage. Then A minus X is equal to A minus X is equal to 100 minus 20 is equal to 80 percentage. Means the final reactant concentration is equal to A minus X is equal to 80 percentage. At that condition, K is equals to 2.303 by 5 into log 100 by 80. 100 by 80 is nothing but 10 by 8. 10 by 8. Okay, is nothing but 2.303 by 5 into log 10 minus log 8. Log 10 minus log 8. Log 8 value we know very well, that is log 8 value is 0.9. So approximately 2.303 by 5 into log 10 value 1 minus 0.9 is nothing but 2.303 by 5 into 0.1. This is on simplification. We are getting K value is 0.046 minute inverse. Okay, then we know that K is equals to 0.693 by T half. Means T 50 percentage. See the T 50 percentage of decomposition of H2O2 is equals to 0.693 by K is equals to 0.693 by K value is 0.046. This is on simplification. The time we are getting 15.06 minutes. So the answer is the answer is around 15.06, means first option is correct. 15.06 minutes. So the first option is correct. Okay, 27. See here indirectly for just 20 percentage of decomposition, the time gave 5 minutes is enough for decomposition of 20 percentage of H2O2. Okay, by using the data, we are find out rate constant of first order reaction, because the decomposition of H2O2 under taking place in first order kinetics only is going on first order kinetics only. That's why we are find out K value. By using that K value, just we are find out 50 percentage decomposition of H2O2 requires how much time? Is nothing but half-life period. T half is equals to 15.06 minutes or 15.5 approximately. According to the options, first option is correct, because this 15.06 is nearer to 15.52. Okay, students. Okay, let's go for next question. 28. 28 question first you read. The first order rate constant for the decomposition of N2O5, K value they gave. Then the half-life period for the decomposition is. So direct question. See the K, first order reaction, K is equals to 6.2 into 10 to the power of minus 4 second inverse. Okay, it's very clear. Now we have to find out its T half life period. Then half-life period T half is equals to 0.693 by K is nothing but 0.693 by 6.2 into 10 to the power of minus 4 seconds. Okay, this is nothing but, this is on simplification, 0.693 by 6.2 into 10 to the power of 4 is nothing but 0.046 triple one seven seven into 10 to the power of 4 is nothing but 1 2 3 4 points is nothing but 1117.7 seconds. Okay, the answer is 1117.7 second means third option is correct. Okay, direct question ma this is. Now let's see the 29 question. 29th question, it's very easy only. The rate constant of a reaction at 300 kelvins is K value they gave, and 310 kelvins also they gave. The activation energy of the reaction in kilocalories we need to find out. So here Arrhenius rate constant formula we need to use. Then at different temperatures T1 and T2 temperatures, then the rate equation is equals to log K2 by K1 is equals to 2.303. Sorry, EA by 2.303 into R into T2 minus T1 by T1 into T2. Okay, this is the formula. Now in this formula, activation energy we need to calculate EA in kilocalories. So log given data, let's see that this is T1, 300 kelvins is T1, and 310 kelvins is T2. T2 temperature at T1 rate constant is 1.6 into 10 to the power of minus 3. At T2 the rate constant is 3.2 into 10 to the power of minus 3 by that K1 is equals to 1.6 into 10 to the power of minus 3. Okay, is equals to EA by 2.303 into 2, because R value, R is equals to 2 calories per mole Kelvin. Okay, but that result final value we have to substitute in kilocalories. Then the calories we need to convert into kilocalories means divided by 1000 into T2 is 310 minus 300 by 300 into 310. Okay, let's see this how many times it will cancel. It is 2 times it will cancel. This will cancel 2 times means log 2 is equals to EA by 2.303 into 2, here 10 by 300 into 310. See this 10 will cancel, then the log 3 value is 0.3 is equals to EA by 2.303 into 2 into 300 into 31. Then EA is equals to 0.3 into 2.303 into 2 into 300 into 310 calories. Okay, so this value, on simplification, this value we are getting 12,850.74 calories. This is in kilocalories, is nothing but 12.85 kilocalories. Okay, so the answer is 29. The answer is in middle. 12.85 means that activation energy is in between 12 to 13. So first option is correct. First option is correct. Let's see 30th question. It's very easy, dear students. 30. The rate constant, the activation energy, and Arrhenius factors of a chemical reaction at 25 degrees centigrade is equal to rate constant. First one is K. The second one is activation energy A. The third one is Arrhenius factor respectively. The value of rate constant at T is equals to infinite temperature we need to find out. According to that Arrhenius rate equation, the rate constant K is equals to A into e to the power of minus EA by RT. EA by RT. Okay. If temperature is equal to infinity, then EA by RT value EA by RT is equals to 0 because the denominator value is very high. Infinite value means automatically its value becomes 0. Its value is almost 0 because the denominator is very high. Okay, for example, 1 by 1 lakh is approximately 0.000 something becomes. Like the denominator is infinite value means EA by RT is equal to 0. Then the K is equals to A into e power 0, e power minus 0 or e power 0, whatever it may be, is equals to 1. Then K is equals to A. K is equals to A. So, what they are asked, the rate constant, the value of rate constant at infinite temperature. At infinite temperature, at T is equals to infinity, then K is equals to A. What is A value they gave? Arrhenius factor. Arrhenius factor is equal to 6 into 10 to the power of 14 second inverse. So the answer is 6 into 10 to the power of 14 second inverse. Second one is correct. Okay. Let's see 31. Here 31 question. See the remaining graphs. Third one is the graph is being like this. This is the reaction coordinates with respect to their activation energies. A is converted into like this, it is present, and the fourth option is none of the above. Now what is the proper graph? Let's see, it is exothermic reactions is taking place in 2 steps. Means the 31, the reaction is taking place in 2 steps. Taking place in 2 steps. The first one is slow step, the second one is fast step. So the graph is being like this, in which the reactants A plus B. Exothermic reactions means exothermic reaction delta H is equal to negative. Delta H is negative means the energy of products minus energy of reactants. Energy of products minus energy of reactants is equal to negative. Okay, so automatically energy of reactants is more than energy of products. So like we have to choose. This is correct graph. Here, this is the energy of products. This is product, this is reactants, A plus B. Here reactants energy is more when compared to products, and this is activation energy. This is intermediate. intermediate, its activation energy is low. So this activation energy is low. This is the activation energy of intermediate. Activation energy of intermediate. This is the activation energy of reactants. This is the activation energy of reactants. Okay. Activation energy of reactants. So the correct graphical representation is second option. Sorry, the correct graphical representation is third option. So the answer is third option is correct representation. Okay, students. This kind of questions also very important. Previously in NEET and JEE examination they are asked this kind of representations. Okay. Let's go for next questions. Some previous JEE mains questions. Let's see. The first one. The time for half-life period of certain reaction A is converted into P. A is converted into P. Its T half is equals to 1 hour. T half is equal to 1 hour when the initial concentration of A is 2.0 mole per liter. When its initial concentration A0 is equals to 2 molar. And T half is equals to 1 hour. Okay, it is zero order reaction. It is zero order reaction. Okay, students. Then how much time does takes for the concentrations changes from 0.5 to 0.25 mole per liters in zero order reactions? We know that for zero order reactions, K is equals to, what is the formula of K for zero order reactions? K is equals to initial concentration A0 by 2 T half. Then T half they gave, that is A0 initial concentration is 2 by 2 into 1, then it will cancel. K is equals to 1. K is equals to 1. 1 mole per liter our inverse. Mole per liter our inverse, that is K. But K is equals to R naught minus R by T time. So is nothing but 1 is equals to, the concentration is changes from 0.5 to 0.5 to 0.25. At that conditions we have to find out T value. Then T is equals to 0.25 hours. 0.25 hours. So the answer is third option is correct. Okay. See here, first data, half-life period, when the initial concentration is 2 molar, half-life period is 1 hour they gave. According to that K value we are find out. So that K is equal to change in the concentration with respect to time. So change in the concentrations from 0.5 to 0.25. In that concentration changing period, we have to find out time. How much time is required for the concentration is changes from 0.5 to 0.25 under zero order kinetics or zero order reactions. Then the T we are finding out, that is 0.25 hours. Okay, let's go for next question. Second question. The rate of reaction is double for every 10 degrees rising temperature. If temperature is increases 10 degrees centigrade, the rate becomes double. We know very well this temperature effect of the rate. So then what is the rate if the temperature is increased? Temperature increased by 50 degrees centigrade, then the rate is increased how many times we need to find out. In this case, the rate is equals to 2 to the power of T2 minus T1 by 10. Okay, students, here the temperature is increased from 0 to 50 degrees Celsius. Then the rate is nothing but 50 minus 0 by 10 is nothing but 2 power 5 is nothing but 32 times. So the rate is 32 times increased. 32 times increased. So the answer is second one. Okay, let's go for third question. Okay, students, the third question, parallel reactions they gave. A is converted into B. Its rate constant is K1. Okay, and the A is converted into C. Its rate constant is K2. And their activation energy relation they give. Its activation energy is EA1. Its activation energy is EA2 is equal to 2 times of EA1. Okay, then what is the relation between K1 and K2 we need to find out. See, for this we know that K is equals to A e to the power of minus EA by RT. According to Arrhenius equation, K is equals to A e to the power of minus EA by RT. Then the K1 is equals to A into e to the power of minus EA1 by EA1 by okay, EA1 by RT. EA1 by RT. Okay, that is first one. Let's see second one. K2 is equals to A e to the power of minus EA by EA2 by RT is nothing but K2 is equals to A into e to the power of minus EA2. EA2 is nothing but 2 EA1. 2 EA1 by RT. Okay, this is second equation. Now you have to do equation 1 by 2. Then 1 divided by 2, K1 by K2 is equals to A and A will cancel. Then e power minus EA1 by RT whole by e power minus 2 EA1 by RT is nothing but K1 by K2 is equals to e to the power of this is goes to upside means positive, then is equal to EA by EA1 by RT. Then K1 is equals to K2 into e to the power of EA1 by RT. EA1 by RT. So the answer is K1 is equals to K2 into e to the power of EA1 by RT. The second option is correct. Okay, students, let's go for fourth question. Okay, let's see. Consider the equation. Cl2 plus H2S is converted into S plus 2H plus 2Cl minus. This is the equation. For this equation, rate is equals to K into concentration of Cl2 into concentration of H2S. See its mechanism. According to its mechanism, the mechanism is taking place in two ways. The first one is A, that is in A type mechanism. In A type, let's see, in the A type, Cl2 is plus H2S is converted into H plus Cl minus plus Cl plus Hs minus. They gave. This is slow step. So slow step is rate determining step. Slow step is rate determining step. Rate determining step, RDS. Okay, hence rate is equals to, for this first step or in the A step, the rate is equal to K into concentration of Cl2 into concentration of H2S. Okay, now let's see B type. The B type mechanism, the slow step is this one. This is the slow step. So for the slow step, the rate is equals to K into concentration of Cl2 into concentration of Hs minus, is not matching with the rate of the reaction. So yeah, which one is matching? This is the correct. Is it is equal to the rate of reaction. So experimentally, the A mechanism, the rate is matching exactly with the rate of reaction. So the answer is A only. So the answer is fourth option. Fourth option only correct. Okay, students. See here, first we have to keep it in our mind. It's very easy only. First overall reaction, its rate, expression or rate, they only give. So among that two mechanisms, which is exactly matching with the rate of the above reaction? Here both are matching, B only matching, A only matching, or neither A or B. So the answer is A only matching. So among that, the reactions for every case, the two mechanisms, the rate, the reaction is going place in two steps. Going place in two steps, in which the slow step is rate determining step. In the both slow steps, rate determining step. According to the rate determining step, rate expression or rate equation are written in the A type of mechanism is exactly matches with the above rate expression. That's why the answer is A only. A only correct, but not B. But not B. Okay. Let's see for fifth question. Fifth question. Okay. The fifth question, 2A plus B is converted into C plus D. See here, the initial concentrations of A and initial concentrations of B they gave, and rate of formation. See for this case, what is the correct expression for the rate of formation of C? Rate of formation of C, that is dC by dt is equal to rate, is equal to rate. So for this, from the experimental data, the initial rate of formation of C, the rate concentration of A is 0.1, concentration of B is 0.1, the rate is 1.2 into 10 to the power of minus 3. If concentration of A is constant, concentration of B is constant also, B is increased. If concentration of A is constant, concentration of A is constant, and the concentration of B is equals to 2B, but rate is not changing, rate is same, means order with respect to B is equals to 0. Order with respect to B is equal to 0. Okay, if concentration of A is equal to 2A, if 2 times it is increased 2A, then the rate becomes double. Okay, from C, this here, the rate becomes double from the third equation. This is third data. From the third, then order with respect to A is equals to 1. Therefore, rate is equals to K into A power 1. So the rate is nothing but formation of concentration of C. Therefore, dC by dt is equals to K into concentration of A. So the answer is fourth one. The answer is a fourth one. Okay, students. So complete chemical kinetics level 3 and level 2 objective questions we are completed. So especially for level 3 questions are more useful for JEE. Level 2, level 1, those all kind of questions are mostly coming for NEET examination. Once you go through that previous NEET and JEE examination, we'll get some idea about how to solve chemical kinetics and what type of questions are coming mainly. So the mainly zero order reaction and first order reactions related rate constant formulas, half-life, and rate how many times it increases or decreases. So that kind of questions mostly they're asking. Those all are very, very important and very easy also, we can solve very easily. But the thing is, we have to keep it in our mind. Some formulas and basic information we have to keep it in our mind. Then we can solve very easily objective questions. Okay, students? Okay, the next class will continue. The next class will continue electrochemistry objective.